Hey, this is Professor Snell. I want to do a brief video going through assignment 1, exercise 1 for ES Environmental Systems 2. So let's just do that. Oops, wrong thing. Here it is. Okay, so uh, and why am I doing this? Well, I just feel like it's something we did last semester. We should know it, but maybe people are forgetting or at different levels of skill. So just want to talk about it briefly. The first thing that we're revisiting this techniques from the first semester. Um, so first thing is to make sure that you have the software, and that is you should have access to this sheet from last semester. You really should just have the software, but if you don't, these are both free programs, Climate Studio and Climate Consultant, which are mentioned in this assignment. So you should have access to them. So make sure that you have those working. And why? Well, one thing is this is the last assignment that we're officially using them in, I think, for this semester. But you should use these in your other projects, and not because you're going to get graded on it. It's because it's very useful information to make your designs better. And whether or not a professor asks you to make it better in this way, I think that they will acknowledge it's better once you access this data and improve your designs based on the sun and wind and other variables. Okay, so we've got it set up, um, and now we want to locate or create a massing model for your design for project site. Um, Talked about that in class, or we'll talk about it in class. So we have been given access to where your site is, but you're not designing on the site. You're just making a context model so we can look at the sun and wind and other variables. Um, I did another video that's available on Canvas talking about how you can make a model like this. This is my facsimile of your construction of your design for site. Um, if you have any skill in SketchUp, it's pretty easy to do this. And if you don't have it, I think it's a good thing to learn. Now, I know that we don't use SketchUp much at NYIT, and so I'm not saying you should be using this in your designs. That's up to your professors if they don't, if they do or don't want you to do that. But I think for making a context model, it should be okay, and it's a very easy way of doing it. But the point is, whether or not you do it this way or some other way that we're not covering in this class, you need to get a context model together for this assignment. Um, all right, what's next? Access the climate data site closest to the site. So we do that first in Climate Consultant. I was playing around with this earlier, so I've already done it, but let's just go start a new project. I don't know why it keeps opening it up over there. Remember, we can download a new EPW file by going to the Energy Plus website. If we don't even know the place, we can just zoom in to a location and find something close. And if we don't have an exact location or know where there's some climate data, it's these little location markers are what you're looking for. So I'm just going to go to JFK because it just happens to be here. If I click on it, I can go to the folder. One thing you can do is download the data. That's great. And I've got that. I can use it in Climate Studio. Climate Consultant likes you to copy the link, or it makes it easy. If you copy the link, then I can just paste the link here. Now we've got all this awesome climate data and access to all the different cool charts that summarize it in different ways. So we've accessed our climate data. What do we need to do? Determine the times of year that will generally be devoted to heating or cooling building operations. So how are we going to do that? Well, there's two ways we can do it. Well, there's three. A really good site. Let me see if I can find it quickly. Where did I put that? Yeah, I think it's here. This weather.gov site is a great place to find, for example, if I go to somewhere around New York, I can do Kennedy monthly summarized data. I can look up rain, which is great, or precipitation, snowfall, but I can also get heating and cooling degree days. So here's the Here's the average for this whatever time period that they're doing it here. Um, so that's a great place to get heating and cooling degree days. There's also a lot of basic information, of course, in um, Climate Studio. So we can find things like average dry bulb temperatures and stuff in this chart, or we can go and look at temperature ranges. This is a really good way of seeing. So we're basically, here's our comfort zone up here, right? The gray. Where are we going to need to heat? Well, definitely in November, December, January, and February. Well, March too completely. We could also include October probably. So I'd say October through March, definitely, maybe April are our heating months, and then May through September have some cooling in them. You could just also skip April and say, well, or maybe October and say, I can just, I can find passive ways of getting these hours up into the comfort zone. Anyway, you need to pick a time frame for that, for heating and cooling. Another place we can do that is in Climate Consultant. So let me just open up this. Okay, we're in LaGuardia here. Doesn't really matter. But actually, let's go ahead and remind ourselves. If I come to this tab with the site analysis on, I can bring in climate data. And if I go to my downloads, where I just was, there's the JFK. Open it. So I've got JFK. And this is a great chart here that has a lot of, we've got the Köppen climate zone. We always want to know our ASHRAE climate zone. This is mixed 4, so 4A. Um, we get, average animal temperatures, average total solar insolation. These are all great things. But be careful. I would not use these heating degree days and cooling degree days. There's something wrong with them. I don't have no idea what it is. But you can see here that we have 2,627. And NOAA is telling, which is our government organization, this is their website, is telling us 4,663. I know that's much more accurate. So there's something wrong with or I'm clicking the wrong button or something in the Climate Studio heating and cooling degree days. I'm going to check with them on that. I just haven't ever done it. Um, okay, but that's the idea, is that we need to find generally when we're going to be heating and cooling. Then what else? We might want to compare then those months to the um, sky cover range. And if you screenshot them and put them side by side, you can ask yourself, well, if I do want to be heating if I do want to get sun into the building in the winter in my heat when I need heating, is it too cloudy and it's not worth it? Or, so those are the kind of questions that are being asked here. I don't know if that one specifically, so let me just go back and look. So we're determining the time of year that will generally be devoted to heating or cooling. I think I covered that. If you have questions, let me know. The directional sources of cooling, season, and undesirable heating winds. We have two ways of doing that. Others, but we have there's a lot of different places that wind shows up in Climate Consultant. Like you can go to the 3D chart, I think, and there's wind in here, wind speed, that you can play around with, average, daily, monthly average. You can use the wind wheel. I personally find this kind of confusing, or I just don't find it graphically very powerful. And I think I have a slide in my summary or my review of climate making this point. I like using the Climate Consultant wind rows. So I'm going to go to, well, I can just do it here. If I go to site analysis, I'm in sun, turn on my wind rows, go to, probably better to be at the top. No, for some reason, is that just my roof? Let me see. My overhangs. Huh, where is that? Sorry, I don't really know this model very well, obviously. It's definitely not the, oh, it is the site. Oh, that's right, I just made a square site. Anyway, let me turn off my sun. I'll leave the shadows on to make it white. So if I come to my Windrows tab and I say, what were we saying? It was like these actually go up, they wrap across each other. So let's say we were going from, let's say for the winter, I think we were saying it was like November through March, maybe. Um, and you have to turn on and off if you change your parameters here. If you want to see it in the main window, you can also, of course, print it. But anyway, I usually like to step this up to a couple miles per hour. Um, so what we're saying now is that during the winter, this is in at JFK, this is where the wind's coming from. That's interesting information. If we then go and switch this to, uh, let's see, what do we have? Um, let's go like June through September. So this is our heating. Quite different, right? So wait, do we have to? Yeah. Oh, actually, that's interesting. I have this flipped around for some reason. Let's go back to, I have no idea how that happened. Anyway, so summer winds mostly from the south, and then winter winds heavily from the west. Very interesting. And that's what this question is asking us. Now, I won't show you, but then I just find this more confusing, but you're completely welcome to use it if it makes sense to you and you can make it and you can use it to your advantage. Um, okay, so we did the heating and cooling, building operation, the directional sources of desirable cooling season and undesirable heating season wind, optimal shading angle for nominal southerly and westerly direct sun exposures. Okay, so what we're talking about there, I know, is this in the slides that I prepared. So if we let's just go first to Climate Consultant and look at the shading chart. So what is this telling us? We're at December through June, and here's June through December. So and the red coloration is for temperatures or times of, I think it's every 15 minutes that are greater than 75 degrees Fahrenheit, and the blue is for less than 68 degrees. So in the summer, obviously we have more time when it's hot than we do in the winter, even though the trajectory of the sun would be the same because it goes from the winter solstice to the summer solstice and back around in a circle, never-ending circle. Um, so uh, But then what about the sun shading angle, the optimum sun shading angle? What are we talking about there? Well, if we turn on um, the solar display calculator, we get this, what I find sort of confusing description here. I'll try to explain it. So let's just table this for a second and look at these slides. Um, so I should remember that you have to have both of these to understand the year. There's two different charts. If you don't understand that, ask me. When it's all when there's the sun the shading calculator is not on, it's assumed that basically whatever face we're looking at, in this case it's bearing directly south, is completely unshaded. And then if we start shading windows, then we get something called a profile angle. So here is our sill, and if we take a straight line out from the sill and then uh, figure out the angle of the line that goes from the edge of the sill through the overhang. That is the angle that we're seeing on this chart. It's called the profile angle. And so the point is that, so here we are at June 21st at noon. If I have the profile angle set at 80, as I've got it modeled here in SketchUp, then our sill is completely in the sun. And so we can see that this line right here is June. So we have June, July, August, September, October. November, December, and then if we switched it to the other 6 months, there'd be the same lines, but they would have different names, right? Um, and so we see that we are completely in the sun, in our sill is. And then at 70 degrees or 72 degrees is where I've got it here. That's right where it should start shading the sill in on the summer solstice, which is where we are, summer solstice. So that makes sense. And then if we keep going, we're at 56 degrees. We're just shading. By the way, these are at like the 21st of the month, so this would be September 21st here. So June, July, August. So this is sort of right at the beginning of September would be where this 56 degree would be. I put it at September 1st, and it's about right. That everything above the sill is shaded, everything below it is in the sun. And so if we keep going, I guess that's all I did. Um, you get the point that we could then we can quickly determine using this chart in Climate Consultant um, when our sill is shaded. Now, I don't understand how that really completely helps us because we don't know how big our window is, and so how much, like when I'm here, oops, sorry. I should have, I thought I did add, well, I did here. So we don't know, we know that there's something that's in the sun above the sill, but we don't know how much of that window is in the sun and how much of it's in the shade. Anyway, I think in the assignment, when we're saying what's the optimal, you can use, well, okay, here's the other thing of it. If we're here looking, what would be the optimal for heating? I mean, so we want to, in the June to December, we're going to want to shade as much as we can in, we're going to want to get rid of as much red as we can and keep as much blue as we can. So that'd be like, okay, 50 degrees looks really good. But then if we switch to the second half of the year, we're shading a lot when we want sun. So we have to figure out what we think is the best. What's the optimal? Sometimes this thing is hard to, I don't know. You have to decide that. What's the best place to have um, this profile angle? Um, and so hopefully that's somewhat clear. Um, I know that in my class last year, I didn't really use this chart, and I would just personally, I would go into Rhino or SketchUp or something and do this. Do I have an open? Yeah, this guy. I could bring in an overhang. Let's see. Do I have some overhangs here? I think I do. Yeah, I could do something similar to that if I had windows in this model. Um, and I could set angles, profile angles in Rhino or SketchUp and do something similar. So, and then I would have more information about what's actually being shaded in the windows. But for this assignment, just get something basic. It's fine to use this interface. And so okay, so we have, what did we just do? Oh, optimal shading angles for nominally southerly, and nominally westerly direction sun exposures, direct sun exposures. So the way you do that with this chart is that I can now move this bearing angle wherever I want. And so if I'm going to go all the way west, I now can adjust my profile angle and see how it's affecting um, the sun in this climate, the shading in this climate. By the way, you notice that as I'm changing this, these numbers over here change. That's pretty cool. Telling us how many hours are exposed and how many hours are shaded in the when it's either cooling or heating. Now, I know I'm going through this quickly, and it's review. Also, you can pause and go back and watch again. But you really just need to play with these charts and stare at it and go, wait, what's going on? How do I understand this? As we learned last semester, when we get to the west and the east sides, it can be more productive, or it can be productive to do horizontal overhangs. So I should have said that before. This is for a this mask is for a vertical overhang relative to the sill, so with a profile angle relative to the sill. And this is a horizontal overhang. And you just read, it's from the, I don't really use this very much. I believe it's from, I don't even know what it's going to tell us. We may have to go back to the beginning of it, and I don't want to take the time right now. I think you set it at the edge of the window, but you can check it yourself. And so I bring my bearing angle to directly west, and then if I want to, I can adjust my horizontal um, angle, my horizontal overhang angle with this slider. And so I could use a combination of these two, and I could model that also in SketchUp or Rhino and see how it compares. Okay, so that is the so we finished this much. Perform a direct solar study showing positions for equinoxes and one solstice. We do that in this class. We've been doing it in Rhino. So you set your. We come over here to the sun, and it's very easy because there are presets here. So I can go to the winter solstice and go to 9 a.m., then noon, then 3 p.m. You want to, you see in the instructions it says make sure for whatever. Let me see if it works for this. This one I didn't. It's because the colors I used in SketchUp, it doesn't. The shading doesn't read that well, but maybe as to make a point. Um, if I let's see if it's going to work. If not, I'll abandon it quickly. I decided to bail on that because I have not yet set up the uh, the sun and the wind in a position that would be helpful. So I'm going to go ahead and just go back to the other model I had open. But I'll make the point that he's making, or that's being made in the assignment, that you want to make sure that you're doing this on a context model that's of a size that's useful in terms of seeing the shadows. A lot of times I see people making these giant context models where you can't really see what's going on. You just see these shadows very, very faintly. Think about what you're doing. The point is to see the shadows. Also, this is really about how the site is being shaded by the context. So if there's trees or buildings, not how your building is shading something. So you're not going to have a building in your model, but you will have a context, and that's what we're looking at. Um, Let me see if I have, yeah, like so if I'm looking at your site and I start playing with the sun, this is just in SketchUp, obviously, I can see how these buildings are shading. So this area, oops, this area here is the buildable area, and as I move through the year and through different times of day, so let's say if I just set it at noon and I start at the winter solstice and go to the summer solstice, there's a lot of information I can gain from where I might want to put a building on that site based on just on the sun. I can also quickly see how the sun's moving through the day, and I can do that either in SketchUp or in Rhino. And we want to do that. Well, I just got this set up here. Where we're seeing the full year. So that was the winter one at 9, 12, and 3, equinox at 9, 12, and 3, and the summer at 9, 12, and 3. So you're doing that in either SketchUp or Rhino, or I guess something else if you have access to it. Okay. And again, read the instructions. I said them quickly, but make sure that this is meaningful information. Um, so that's this. And this is where he's saying, don't show big blocks of content. which is all too small graphically to be useful. Exactly. um, okay, then finally we're doing a radiation analysis or equivalent on the site in context buildings. Note the total radiation available on portions of the site in full sun throughout the year and any that are sometimes shaded. Using a context building, note the typical solar radiation kilobTUs per square foot per year on a building face unshaded by other buildings in each of the cardinal directions. Okay, what's going on here? Well, that's a great it's great that I showed this then. So let's say we did this in SketchUp. It's prettier than it is in Rhino when we're doing a sun study, but we're not getting any real data here, right? I can just move. I can see physically how the sun's moving, but how much is that changing the amount of energy that's hitting these different faces? We can do that pretty easily in Climate Studio, and hopefully you did that last semester. Um, so I've already run some models here as an example. So let's just go to those. By the way, if you don't, one thing that sometimes people don't realize that if you want to turn off, let's say I'm looking at one of these, and then I'm like, I want to go back and look at my model because remember, if I right now if I'm looking at a radiation map, for example, in Climate Consultant, I can either have um, things turned on in the model or not because the radiation map shows up on its own, and that's how if you're just for radiation maps are better than some others or easier because they just show you what was in the actual simulation. I'm going to go back over here and just turn off the sun stuff. Um, okay, let's talk about radiation maps again, just in case you've forgotten. So I'm going to turn off. If I go to the workflows and I go to radiation map, I can actually turn off. To go to results, I can turn off the simulation, and now I just have the whatever layers I have on. So I'll go ahead and turn on some stuff. Trees, context buildings, that's all we need. We probably need overhangs too. So first thing we have to do a radiation study, a radiation map, is select materials for our, this is very important. If you don't do it, you get inaccurate results. So whenever I have turned on, when I go to materials, these layers will show up and I can add materials to them just by double clicking on the material tab next to the layer, and then I can come choose from these presets. Remember, there's glazing and other, so you can do, you have to choose which one you want. So you select surfaces for anything that you want to have in the simulation. Remember, just because it's showing, if you don't have it if you don't have it with a material on it and as an identified surface, it will not show up in the simulation. So we've got materials to find, and the next thing we have to do is surfaces. And I have tons of surfaces. Just the way I did this model is a little bit loose, but basically what all we have to do is if I were to come and select a building, let's say I just wanted this building to be these surfaces to be in my model. I then say add analysis surface, give it a name, say OK, and it would be added to this list. And then I can turn them on and off for models as I like. So now I've got that this one overhang is in this model. I've got in this it's going to be in this simulation. I got these trees, and I've got all these buildings. Let's see. See the buildings turning on, and then why is there so much drains? Because there's different surfaces. Um, because wherever, like for example, you can see that where I did these, I built little plinths, little foundations in SketchUp before I brought this in, and so that became a different terrain. And then I would just hit run, and it will start generating the radiation map. Okay, I'm going to stop it because I've already run some of these. Let me now go back and let me turn my actual model off. The different layers. Okay, and I'm going to, so I've run several models, and let's look at the results. Oops. I go back and forth between problems, and I always forget which one of the shortcuts are on my mouse. Okay, so here we are, in this model, the simulation we ran with the trees, and we can see the face of this building has. Oh, and by the way, we can do total solar exposure, direct, indirect. We can, if you forget what those mean, we can talk about it. I'm going to do total solar exposure, and I'm going to do. And actually, really, I could just do direct probably, and do cold hours. And but you know what I'm going to do? I think it's better to do both direct and indirect. We can talk about the difference. Um, but so I see that with the trees, and I'm just using cold hours because I want to look at on this south face. It's not exactly south, but southwesterly face. Um, I want to see if I'm getting sun in the winter because I may want to have sun coming into the building, right? So, and I could look at this in SketchUp, but I don't get any actual data, numbers. So here on this sensor, which all these little black dots are sensors, I'm getting 48 kilobTUs per square foot per year with the trees on during the cold hours or during the heating season. Now, if I get rid of the trees, let's say I was going to cut them all down, this exact same sensor has 133 kilobTUs per square foot per year, so over double on this space by with or without the trees on this site. Now that's really important information to have, and I can get it really quickly. This model is very easy to make, and I can make it quickly. So powerful, 50 to 133. But now I actually did an overhang on this space, so let's do the same thing for. Let me adjust a little bit. I'm gonna do this, I guess. Huh. Not sure why it's not letting me adjust in a meaningful way, but okay, this will do it. Um, I see why. Okay, anyway, I'm not gonna run the I'll be able to see it. So if I'm on this face, uh, trees are in the way. I'm on this face with trees 67, without trees 134. Let's say in this case I was like, you know what, I don't have trees, but I want to get to a much lower amount of sun on this face. I could add an overhang. How much am I getting there? Well, it looks like about 60 um, kilobTUs per square foot per year in the heating season alone. And let's remind myself, if I go back to the tree version, 67, so I'm actually getting a little bit less with this overhang than I would with the trees. So that's the kind of stuff you can learn really quickly, and that's what you're being asked to do in this assignment. Is there anything else? No, so, oh, that was about the building faces, right? The shaded, and we could do that for all four cardinal directions, right? So I could say, and I could do it for all year if I wanted to, whatever. I don't know. I'm not reading exactly the instructions, but so with the trees, this is 268. Without them, it's 278. Not much difference. That's interesting because of the facing. You can think about why that's true. Overhang's not going to affect it. And the north's going to be much less, right, for all of them because of the way the sun moves through the sky. So with the trees, it's 110. Without them, it's 116. The overhang's not going to affect it. So seems like the southern side is the one that's being most affected, which makes sense in this in the northern hemisphere. Um, then you were supposed to look at parts of the, again, this would be in connection with your site for your studio. There's parts of the site that are shaded by buildings and parts that aren't. So you would go in so maybe if I did a tree, let's just pretend like this is the site. And so I can look at the site itself and say this portion is, 268, 310. I can talk about just how far away it is from the lot line or something, and when how I get more sun. And then as I get into the trees, it gets to be less, and I could make a comparison, percentage comparison, or a ratio between the two, or between different portions of the site. So that's what you're supposed to be doing here. And then just make sure you read this. You need to put this all together in a clear little presentation, graphic presentation. Just read these instructions and follow them, and you should be fine. Let me know if you have any questions.